Fine, we'll start. Good evening. We'll start. Online. What about the audio and the video? Start. Right. Okay. So today we will be having part 2 of paper 2. Right? Part 1 ka last day part 2. Right. Since online students are still joining in, we'll start the first question. I mean, I'll give you the time to write the first question. Go to question 1. Question 1. For question 1, now it's 7-3. Take 10 minutes and complete the question. Question 1. 7-3 to 7-13. Complete question 1. If you have already finished question 1, you can go to the next one. That's fine. There's a small typo. Did you notice it? It should be a metal sheet with circular hole of diameter D, not radius D, diameter D. It is correctly marked in the figure, right? It's not the radius, diameter. Guess කරන්නත් පුළුවන්. D කියලා දීලා තියෙන්නේ. It's a diameter. Diameter D. The lengths of AB and D are not of centimeters. And another small mistake, the thickness T should come there. The thickness, simple T of the sheet, right? Cut off T from where it is given and correct it as the thickness T of the sheet. That's it. Unit 1 completely done. Unit 1 cover velani. Measuring instruments speedometer करना speedometer question आती है first एक करना बोलो measurements cover कर लेने दे मैं finish measurements कर लेने दे measuring instruments first two answers are correct first two are correct ಅದರ paths ಅದರ right shall we start right first one let's see right first one a metal sheet with a circular hole of radius d is shown in the figure. The lengths A, B, and D are in the order of few centimeters less than 10 centimeters. The thickness T of the sheet is of the order of few millimeters. First one, what is the most suitable measuring instrument to measure the thickness of the metal sheet? What's it? No, not the vernier caliper. There are two things, that is micrometer screw gauge. Micrometer screw gauge, two things. One is, it says that is few millimeters, right? Then in terms of accuracy of a micrometer screw gauge is higher. Plus, there's very important thing, that is a metal sheet. Since there is a metal sheet, if you try to use vernier caliper, its thickness can get damaged when you try to keep it tightly between the vernier caliper, right? Maybe internal jaws, right? That is what happens, or external jaws. So therefore, micrometer screw gauge is the only instrument we have a mechanism that we can indicate, we can get an indication to which degree or to which tightness it has been tightened up, right? That indication is there. So therefore, if you are measuring metallic ones, maybe metallic balls, metal sheets, right? So kind of ones are malleability again. The things with malleable things, malleability the best instrument to use is micrometer screw gauge. The reason is we can get an indication as a ticking sound when you rotate the thimble head. When there is at the proper tightness, then it won't damage it. Otherwise, metal get damaged, right? Then whatever the value you are going to measure will be different from the actual value. That's the thing, right? So micrometer screw gauge only, using vernier caliper, we can't take such a measurement. Micrometer screw gauge. B. Right, B. What is the important experimental step that should be carried out before using the above instrument? Experimental step, what is it? Checking zero error. Checking zero error. So no need to explain how to check the zero error. Only the step is asked. Step is checking zero error, right? Step is checking zero error. See, the above measurements were taken using a vernier caliper. State which parts of the vernier caliper. Vernier caliper you thought vernier caliper. The above measurements were taken using a vernier caliper. State which parts of the vernier caliper should be used to measure each of the following dimensions. For ABD, it is vernier caliper. Initial question that is for the thickness, no? For thickness, micrometer screw gauge. Right, A is a length. Then external jaws can be used. External jaws. C, A, external jaws. External jaws are also called outer jaws. Both are fine. External jaws or outer jaws. B is also length, right? Then length should be measured from the outside, no? Again, external jaws. External jaws or outer jaws. Then D is a diameter of a hole. Then it should be measured from inside. Internal jaws. Internal jaws. Or that is called inner jaws. Right. D. What is the most suitable laboratory instrument to measure the mass M of the metal sheet? Right. Most suitable one. Okay. What are the answers? To measure mass of this. Electronic. Correct. Electronic balance. There are more. Right. There are more possible ones. Electronic balance is correct. What else? Electronic. Electronic balance is correct, or else 4-beam balance, not the triple beam balance. 4 beam balance, electronic balance, correct, or 4 beam balance. Okay, E. E. Using the above measurements and standard formula, write an expression for density of the metal. Right. So mass is also given. In terms of mass and volume, first tell me what is the relationship among these quantities? Density, mass and volume. Density equals mass or volume. So mass is density into volume. Right. Density equals rho equals MOV, mass or volume. Mass is given by using right expressions. Density. Density right. Then mass is given in the previous step as M. Then you have to find volume here and plug the value here. So how to find the volume? That is a metal sheet with a hole, something like this. A metal sheet with a hole, and it has a thickness, right? Something like this. It has a small thickness. So we know volume can be written as cross-sectional area into length or thickness now. Then if we can find out this cross-sectional area directly, this cross-sectional area into thickness gives volume, right? Find the cross-section. Cross-section is given as AB. This cross-sectional area is AB, but there's a hole inside. It should be subtracted. A circular hole. Then area of a circle is 5r squared. R is not given, instead D is given. So radius is diameter over 2 squared. Right? This part gives the area. Right? Remaining area here. AB is the total area. From that, subtract the area of the hole. 5d over 2 squared. Now, this whole thing into thickness. Thickness was given as T. No? So this is the volume. Plug that volume here. So if you can do it here at once, that is totally fine. This is just for your clarity. Right? Then this is AB, plug it here. Fine, no need to simplify. Only the expression is asked now. No need to simplify. You can consider this as a final answer. Simplification is not mandatory. Only the expression is asked. F. Measurements obtained at several places for the thickness of the metal sheet are given below. 3.50 millimeters, 3.51, 3.52, 51, 53, right. What is the least count of the measuring instrument? 0.01, right? So what's the hint we have? The readings given, no? The readings given. Always a reading can be taken to the number of decimals we have in the least count, right? So if you have a least count of 0.1 millimeters, all the readings taken from that particular instrument should be having only 1 millimeter decimal, 1 decimal millimeter. Likewise, now here we have 2 decimal millimeters now. Plus, there is another thing you have to check. Check whether they are like all values. So sometimes it can be only even values. Such cases are there because now if it was, listen, now in such a question, if it was say 0.02, all the measurements should have the second decimal as an even number. Even decimal like multipliers of 2. If this is the least count. Now in this case, both are there, no? 0 there, no? 1 there, no? 2 there, no? Second decimal. Therefore, this is 0.01. Otherwise, if an instrument like this was used with a least count of 0.02, the measurements will be like 50, 52, 54, 56, likewise, only the even multipliers, even numbers. Since all are there, that is 0.01, right? Two things to check, number of decimal places plus the behavior of the decimals, right? Because 0.2 or 0.02 least counts are there in some instruments. That is how it should be checked out. It should be ensured, right? Now in this case, since all values are there, part F1 least count is 0.01 millimeters. 2. 2. Calculate the mean thickness of the sheet. Very easy. Mean is the average. Then these values are given. So mean is given by 3.50 plus 3.51 plus 3.52 plus 3.51 again plus 3.53 over 5. What's that? Simplified. What's that? 3.59. 51. 3.514. So in this answer, you have to, it's better to mention all three decimals. The reason is in the next question, that question is asked, that particular question is asked, right? So it should be 3.514. Part 3. How many decimal places can be included in your answer? That's the question. Now, when you consider the mean value, average value, now you got 3 decimals. But we know least count is only 0.01 containing 2 decimals. Then all the readings taken from this instrument should have only 2 decimals. So, may answer explain the reason for your answer. How many decimal places? Only 2. Only 2. Only 2. Only 2 or 2, right? Only 2. And explain. Explain the reason. Reason is this, right? So explain. Least count of the instrument has only 2 decimal places, 2 decimal millimeters. Least count of the instrument has only 2 decimal millimeters. Least count of the instrument has only 2 decimal millimeters. Least count of the instrument has only 2 decimal millimeters. Right? So therefore, now when we are using this value, this reading, hereafter you can round this up to 2 decimals and use it. Right? So as a rounded value, 3.51 is correct. As a rounded value, but here mention this value up to 3 decimals in this particular question because the following question is asking about this. So make a question, right? That's logical, no? That's logical. So in other cases, if you got something like this, what we do is you can round this up to 2 decimals. So the number of decimals you have in the least count. If your least count has only 1 decimal, then to 1. If it has 3 decimal places, to 3. Likewise, you can round it up. Right. Okay. Any questions about this? Question 1. Clear? All good? Clear? I am Malin sir. Any questions? Online? Right. If no questions, we'll move on. Right. If any questions, you can ask. Question 2. Go to question 2. Go to question 2. 7:26. Again, try in 10 minutes. Question 2. Try question 2. Finished? Right, question 3.
Someone say, what is the reason that it contains only 2 decimal places? My connection is kind of bad today. I get disconnected very rarely. Yeah, sorry, reason is
the instrument has only 2 decimals. I mean, in the least count of the instrument, it has only 2 decimals. Then all the readings which are taken from the same instrument should have only 2 decimals. If your connection is bad, you can switch to YouTube if possible, because then you can rewind and see, right? Zoom package එකක් නම් කරන්න දෙයක් නැහැ. Otherwise මේ අද වුණ YouTube live එක තියෙනවා. YouTube එකේ බලන්න පුළුවන්. And Aditya, what happened today? Aditya online again. What happened? Right, we'll start. Question 2. Question 2. The spirometer used to measure the thickness of a glass plate is shown in the figure. The circular scale is divided into 50 divisions and the linear scale advances by 0.5 millimeters when the circular scale completes one full rotation. Right. So first thing, tell me what are the other possible measurements that we can take from a spirometer. Now this is about one thickness of a glass cube, glass plate. What else? Spirometer. What are the other possible measurements? Something additional. Tell me. What are the other possible measurements using a spirometer? So in its name itself also, there's a usage. Spirometer. Spirometer is to measure spheres. Spheres means radius of curvature, right? So unique measurement from the spirometer is radius of curvature of any spherical surface. That is why it is called spirometer, right? Unique measurement is radius of curvature. Other than radius of curvature, can measure thickness or depth. Can measure thickness or depth. The unique measurement is the radius of curvature, right? And there's another small difference in the given one. In the typical general spirometer we use in labs, we have 100 divisions, right? In the typical 100 divisions in a spirometer with 1 millimeter pitch, In this particular instrument given, pitch is 0.5, advances by 0.5 means pitch is 0.5 with 50 divisions. Least count is same, but divisions are different. Divisions are different. Radius of curvature, good. Good. Radius of curvature is the unique measurement. Right? When we say spirometer, that is the first thing it should come to the mind. Radius of curvature. Unique for traveling microscope. What is a unique measurement of a traveling microscope? Telescope. What's the unique measurement? Diameters of rubber tubes. That is to measure rubber tubes. Because in all other instruments, it should be fixed somewhere between external torso and inland spindle somewhere. Then rubber gets deformed. It's changing the shape. So that's why we have traveling microscope. The specific measurement of a traveling microscope is rubber tubes, diameter of rubber tubes. Right? So keep them in mind. Right? Write the formula used to determine the least count of the instrument. Formula for the least count. Least count of a spirometer is given by pitch over number of divisions in circular scale. Pitch over number of divisions in circular scale. Number of divisions in circular scale. Right? Pitch over number of divisions in circular scale. Part 1. Part 2. Calculate the least count of the spirometer. Right. Pitch is given as 0.5. So what is pitch, by the way? What is pitch? Pitch of the instrument. There are two instruments. We have pitch. For micrometer screw gauge also, it has a pitch. For spirometer also, it has a pitch. What is pitch? Pitch. Online. Pitch. These are theory parts. The distance travels in one full rotation. Correct. the distance traveled by the screw tip in one complete rotation of circular scale, right? The distance traveled by the screw tip. The distance traveled by the screw tip for one complete rotation of circular scale is called pitch. Now, in this case, that is 0.5 and number of divisions 50. Number of divisions 50. Right? 0.5 over 50 is 0.01 millimeters. 0.01 millimeters. B. One more thing that I forgot to tell you. We are starting the reverse class this Saturday, no? Right? I saw few means actually 2 or 3 from 27 batch also, they were registered for the reverse class, right? If also feel like you have that capacity, because in the reverse class we are starting from unit 10, right? It will cover basically unit 10, unit 11, 9, 8, right? And at the point where the regular theory class of 26 and the reverse class meet each other, I will stop the reverse class, right? And so mainly, since we are studying properties of matter this Saturday in the reverse class, the main links are with mechanics, right? So up to the present theory parts or present lesson in mechanics, if you are comfortable, if you feel comfortable, you can manage, right? You can manage. If you feel like you have that capacity, right? You can join and see. Anyway, first day will be a free day, no? So if needed, you can join and see how the class goes, right? It's a theory class. The only difference is we will be covering the theories in backward direction, starting from the last lessons, last units. That's the thing, right? I just shared the message because few inquiries also came last week, and I saw 2 or 3 were registered from 27, right? And the other thing is now there's a trend of, I mean, nowadays in students there's a trend of writing the exam 1 year before if possible. No? I mean, if they are capable, if they are having that capacity. So for such ones also, you can take that advantage if you have something in your mind like that. Even though your supposed year is 27, if you need to sit for the exam in 26 by covering the theories in an advanced manner, that is something that you can take advantage of, right? That's it. Okay, B1. What adjustment should be made to the instrument before taking a reading? What adjustment? Okay, about a sperometer, there's something special compared to other ones. What is the adjustment? We have to take all 3 legs of sperometer and screw tip to the same horizontal plane, right? To do that, what we are usually using is a glass slide or a glass cube, right? So you have to take a glass cube and keep the sperometer on the glass cube. Then all 3 legs will be in contact with the glass cube and move down the screw tip until the image and the actual screw tip coincides each other. That is the point where we can make sure that all 3 legs and the screw tip are on the same horizontal plane. That is the adjustment, right? What adjustment? Okay, right this way. All three legs and screw tip, all 3 legs and screw tip of sperometer, all 3 legs and screw tip of sperometer should be taken to the same horizontal plane, right? For what is asked, that answer is enough, right? But you have to know the exact thing here. So what is done is you are taking a glass cube or a glass slide and keep sperometer on the glass slide, and by rotating the screw tip, you can move it downwards until the actual screw tip touches its image, because from the glass slide you will see the reflected image. Then what you see when it is contacting the glass slide is the coinciding of the actual tip and the tip of the image, right? So at that point, you have to stop rotation, and then we can make sure that all four are at the same plane. 3 legs and screw tip, all four should be at the same plane before doing any measurement, before taking any measurement. So that is the exact way that we are checking the zero error of the sperometer, right? Instrument wise, we have different techniques now. If there is a vernier caliper, what should be taken to the contact? External jaws. External jaws should be taken to contact to check the zero error. For micrometer screw gauge, anvil and spindle. For sperometer, all 3 legs and screw tip, right? So likewise, it is different from instrument to instrument. What is the purpose of this adjustment? The purpose is checking zero error, checking whether there is any zero error in the instrument, checking zero error. Purpose is checking zero error. To check zero error, not checking zero error. Checking zero error of the instrument. Right, see. 1. Right, after making the adjustment in B1, the positions of the scales are as shown in the figure. State the reading shown in the sperometer. Right, tell me, if there is an ideal instrument, ideal in the sense, if the instrument has no zero errors, when we take all 3 legs and the screw tip to the same plane, linear scale 0 and circular scale 0 should be coincided each other. They should be coincided, right? If not, there is a zero error. There is a zero error, right? Now in this case, 0 and 0 are not coincided. 20 is here, which means there is a zero error. There is a zero error, right? State the reading. Reading means now what is actually asked is the zero error. Okay, so this is what you should know about taking readings from a sperometer. See, in the sperometer, the linear scale is something like this. Linear scale is like this, and the specialty here is it has a this is 5. What is the specialty here? It has a center zero. It has a center zero. In other instruments, right? Usually we have N0 instruments. This is a center zero instrument, right? The reason to have a center zero is because I told you this is measuring both depth and thicknesses. When thicknesses are measured, reading starts from here, the scale starts from here and goes up, travels up. When you measure depth, reading starts, the scale starts here and goes down, right? So that's why it is made as a center zero instrument, right? Both are available, right? Both are available. More general one is center zero. N0 ඒවා තියෙනවා, right? මගේ ටියුට් එකේ මම දැම්ම මම මට මතක විදිහට N0 එක්කුත්. N0 ඒවත් තියෙනවා, right? N0 එකට වඩා it is more convenient to use the center zero one. Easily we can take measurements. So either way, maximum count is only 10 millimeters. Now here that is 10 millimeters each side. I have drawn only a part of the scale. It is running up to 10, right? Maximum reading is 10 millimeters each side. Total length is 20 millimeters. So 10 millimeters each side, right? And the circular scale is made like this. Look at here. Circular scale is like this. Starting from 0 and 10, 20, 30, if there is 100 divisions. So later you can relate it to this one. 60, 70 like this. No? So we know, since this has an screw, this works according to which rule? This is a screw. It works according to which rule? एक rule लगते हैं. Instrument with any instrument with screws works according to right hand rule, right? Works according to right hand rule. So therefore, if you need to move this upwards, this is how you should rotate this. This is the direction of rotation. This gives direction of motion. Right hand rule, direction of rotation and direction of motion. Then if you need to move this upwards, this is the rotation. Now this calibration is done. Calibration is done for this particular rotation. Then this calibration works when you move this upwards only as 10, 20, 30, 40. If you have to move this backwards, downwards, this is how you have to rotate this clockwise. Then when you rotate this in a clockwise direction, this goes as 0, 90, 80, 70 backwards. Right? Therefore, if you take a reading which is above 0, right? If your reading is above main scale 0, reading is just the coincided number of divisions into least count, right? But if your reading is below 0, it travels backwards, no? It rotates backwards. So therefore, reading should be total minus coincided. Total minus coincided number of divisions into least count. This difference is there in a sperometer, right? That's the thing. Always this scale is calibrated for upward readings. Downwards, total minus this should be written. Right? Then downwards the higher rotate to know what you are seeing is 90, but actual rotation is 10. Then total minus coincided. That is how the equation comes. Right? These are respective theory part. Right? These are respective theory part. These are respective theory. Now question 1. State the reading. This is below 0. If this is below 0, reading equals total was 50. Then make 100. 50 minus coincided 20. 20 is given. 50 minus coincided into least count 0.01 millimeters. Right? So that is 30. 30 into 0.01 millimeters, 0.30 millimeters. 0.30 millimeters. Right? So writing this 0 is mandatory. Now, even though that is 0.30, you can't write this reading as 0.3. What's the reason? Least count is for 2 decimals. Then in all the readings, each and every reading you take out from this, there should be 2 decimals. Even though it's 0, you have to mention 0. Right? That's the thing. Even though it's 0, you have to mention 0. 0.30. 0.3 won't be offered marks. Right? Marking schemes right? 0.3 value then 0.30. They are very strict when it comes to structured essays. 0.30, right? After placing the sperometer on the glass plate, the reading is 3.65 millimeters. Find the correct thickness of the glass plate. Right. Now, that reading is coming with this error, then you have to do a correction. See? Now, this is what has happened. And the other thing about a sperometer is, in a sperometer, negative and positive errors changes with the direction of the movement of a screw tip. Right? Another unique feature in a sperometer, a positive error in upward direction acts as a negative error in downward direction. Right? Something like this. See? So again, I'm recalling this theory part. So without knowing this, you can move on with the question. See, now let's say you had a 0 error like this in this instrument above 0. You had a 0 error, right? Now, while you are checking 0 error, we know all 3 legs and the screw tip are on the same plane. This is about the error. This is because of the error. Now, if you are measuring a thickness from this, now let's say this is 20 now. 20. If you are measuring a thickness from this, what is happening is this scale travels starting from here, travels upwards starting from here. Then it is supposed to start from 0, but now starting from 20. So then in the upward direction, it acts as a positive error. 20 will start when supposed to be start from 0. Additional reading initially, it's positive. But in a sperometer, using the same instrument, you can measure depths as well. Measuring depth measure. So it travels backwards like this, downwards like this. Supposed to start from 0 here, but now it is starting somewhere before 0. Then in that case, there is a negative error. 0 will start when before 0 means this is like starting from minus 20. Make a 0 then in this direction, it acts as a same error acts as a negative 0 error. Right? We discussed these things in the theory. Right? It also make anithaga. That is why 0 errors are not defined in a sperometer, because it changes with respect to the measurement you are going to take. Initially, if you had a 0 error like this, right? Now, if you are going downwards, this is an additional reading. Then for downward readings, that act as a positive error. For upward readings, it acts as a negative error. I'll make a summary of the class. Right? Okay. Now, for this particular reading, now it is going to measure thickness. Since it is going to measure thickness, it is like this, no? Starting from here and going to measure thickness. In upward direction, this acts as a negative error. 0 will start when it is below 0 now. Right? Below 0. Then the actual reading is, this is a negative error. Now this error we have found is a negative error for this particular instrument now. Right? So therefore, actual reading is the apparent reading plus this error. Apparent reading plus this error, because always the reading gives with respect to 0 from here to here. When apparent reading, this is the apparent reading. Then for that apparent reading, this error should be added. Right? Then apparent reading is 3.65. Apparent means without doing any corrections. E error is 0.30 millimeters. Right? So the correct reading is 3.95 millimeters. 3.95 millimeters. So this is the underlying theory part. Without knowing the direction of motion of a screw tip, we can't say whether it's going to be positive or negative in terms of the error in a sperometer. In other instruments, we can say, right? In a sperometer, we can't say. Same error acts different ways with the different directions of motion of the screw tip. Right? 3.95. D. Those are like special things about a sperometer. In other instruments, we can say whether it's negative or positive at once, because they had only one directional movement. But this is a bidirectional movement, upward and downwards. Right. D. The following formula is used to determine the radius of curvature of a surface. Right. This is our proved equation. We have proved this in the theory. Radius of curvature. Right. The proved equation. Right. State the usual meanings of the symbols used in the formula. Right. Meanings. A. What is A? What is A? Radius of? No. Radius of curvature of the surface is R. What is A? Online? Distance? Distance between? Distance between any two. This is correct. Right. A. This is a theory part again. Distance between legs. Correct. Yeah. Write down. A is distance between any two legs of sperometer. Distance between any two legs of sperometer. A. Right? Distance between any two legs of sperometer. Legs are located in what? These legs are located in මෙතන geometry එකක් දෙනවා. By using that geometry we proved the equation. Legs are located in an equilateral triangle. Right? All three legs are located in an equilateral triangle. Yeah, equilateral triangle. So usually what we are doing when taking this A is measuring all three and taking the average, right, for more accurate value. Otherwise, they are supposed to be in an equilateral triangle. H. What about H? H is the difference between readings, difference in readings, or we can say distance traveled by screw tip. Difference in readings. Difference in readings slash distance traveled by screw tip. Distance traveled by screw tip, right? R is introduced anyway. Oh no, R is not introduced. Then you better introduce R as well. There are three rules also given. R is radius of curvature. R is radius of curvature, right? Next, 2. The following figure shows the positions of the scales after placing the sperometer on a concave surface. State the reading shown, right? On a concave surface, right? So it doesn't matter whether it's convex or concave, right? For any types of curvatures, the instrument can be used. Sperometer can be used, right? State the reading, right? So we know reading of any instrument which uses a vernier scale is given as reading of vernier scale plus, reading of main scale plus reading of vernier scale. Main scale plus vernier scale. In sperometer, main scale is a linear scale, vernier scale is a circular scale, right? Okay, then from main scale, you have to get the completed main scale. Completed main scale. Now here, it was given, the pitch was 0.5, which means gap between two small divisions of this should be 0.5 millimeters. It was given. In our typical one, that is 1 millimeter. In this given one in the question, that is 0.5. Then gap between these two small divisions is 0.5. Again, 1, 2, 3, 3.5. Main scale is 3.5. Main scale is 3.5 millimeters plus vernier scale. Vernier scale. Now again, we are below 0. 0 is given. We are below 0. Coincided is 20. Then total minus coincided. Below 0 now, it's valid anywhere, right? Total 50 minus 20 into least count 0.01. Right? So this is how it should be written. Simplify this. 3.5 millimeters plus, here this is 30. 30 into 0.01 means 0.03 millimeters. Right? Sorry, 0.30 millimeters. Right? 30 millimeters. Then 3.80 millimeters. State the reading, 3.80. 3.80. Next. Explain the method used to determine the value of A in the given formula. This one. Explain the method. Any answers? So doesn't the instrument have initial reading of 0.3 millimeters? Shouldn't it be reduced? State the reading shown, no? So I found the shown one without any corrections. Right? State the reading shown. So I didn't do any corrections yet. Right? So otherwise it should be corrected. No. No. This is not the actual reading. This is a shown reading. Shown ne kane haldi. So I didn't do any corrections since the shown error is asked. Right. When shown reading is asked, make the shown reading. Error. For the final calculation, you have to do the corrections and do it. Right? So calculation okay, explain the method used to determine the value of A. Any answers? That's a straightforward method. Firmly pressed, yeah. That's the thing. Spirometer should be firmly pressed onto a white sheet. Then we can see the positions of 3 legs after it is taken off. No? Then using a meter ruler or a vernier caliper, you have to measure the distance between any two of the positions. Spirometer is firmly pressed on a sheet, connect 3 dots, form, yeah. Measure the average length. Yeah, that is what you need to explain. Right? So write this way. Firmly press. Legs of spirometer. Firmly press legs of spirometer. Firmly press legs of spirometer onto a white sheet. And create and construct the triangle by connecting dots. And construct the triangle by connecting dots. And measure distances between them using a vernier caliper. Or meter ruler. Vernier caliper is more accurate, right? And measure using vernier caliper or meter ruler and take the average. Value. And take the average value. Right. Part 4. If A equals 3 centimeters, calculate the value of R. Right. Then we should know this. Right. The correct one. No? This is the apparent reading. This is only the apparent reading. So we know there was an error. No? So one way that you can think of this is it goes initially at somewhere here. Like this. It was initially here. And at the point the reading is taken, it is somewhere here. Right? Then move distance traveled by the screw tip. No? Travel distance by the screw tip is only from here to here. This is H in my case. Right? Or else both are fine. Difference in readings. May reading difference gattath hari. Physically right? You can clearly see what happens from the diagram, starting from here and coming down up to this point. Now may reading again. Value subtract right? Then H equals, right? This apparent reading is 3.80. It started from here. It was 0.3, right? 0.330. Then 3.50 millimeters. This is the correct H. Now plug in the equation. Radius of curvature equals A squared. A is given as 3 centimeters. I'm going to convert all the values to millimeters. Right? 3 again, 30 millimeters now. Then this is 30 times 30 over 6h. H is 3.50 plus h over 2, 3.50 over 2. This is a simplification. By 6 you can cancel this 5. Anyone who simplified this? Tell me the answer if simplified. What's the answer? Anyone who simplified this? Simplify simplify value വെക്കുകയാണ്. So if something came in the exam like this, right? So probably you have to use logs when simplifying, right? Logs නැතුව මේක manually simplify කරන්න අමාරුයි. ඒතර logs simplify කරලා ගන්න. Is it 44.60? 17. Check again. I got this. කැල්ලක් ගහලා බලන්න කවුරුද? Check the value and tell me if it's correct. 150 එකක් උඩ දිනවා 150 over 3.50. Right? So 150 over 3 කියලා කියන්නේ it's around 50. 3.5 කියන්නේ yeah 40 something is possible. 3.50 over 2 කියලා කියන්නේ 1.75. සාලිය check again. සාලිය හරිද? simplification එකක් තියෙනවද? එකක් තියෙනවද නැද්ද? හරි? Right. Okay, any questions about question 2? Compared to the first question, the thinking parts of the second question was a little bit higher, right? And naturally it's there when we deal with the spirometer also, because in a spirometer, unlike the vernier caliper and micrometer screw gauge, there are some kind of an additional thinking. My mistake. Okay. So therefore, in a spirometer, that I don't say it's a complexity, but that additional thinking is there when it comes to spirometers. All right. So if no questions, let's move on. No questions, no? All good? All good? Okay. Right, let's move on. Question 1 from message. Right, I'll erase this. Okay, let's go part by part. Try question 1, part A in 10 minutes. Part A. The exact time is 8:17. If you have already finished part A, you can go to part B. If part B is also done, you can go to question 2. Answers. Oh. Okay, mistake. In question 2, it should be two identical balls. In question 2, part B, it should be corrected as two identical balls. Question 2, part B, it should be corrected as two identical balls. Right? Two identical balls. Are there any mistakes in second sentence of question A? Second sentence. A balloon is moving vertically upward with a uniform velocity of 15 ms minus 1. A stone is freely released from the balloon at a height of 200 meters above the ground. At the same instant, another stone on the ground is thrown vertically upwards with a velocity of 15. No, it's correct. About two stones. So at the same time, one is thrown from the balloon and the other one is projected upwards from ground. In the part B1, the bomb has to land on the truck. Truck should be destroyed කියලා නේද කියන්නේ? Truck was completely destroyed. Then can you remember we had one question before about that clearing a face thing from a fruit or something, right? Okay, so you have to think about the point where it should got hit to completely destroy, or rather the best point to shot. That is a thinking part, right? මොන point එකටද best shot එක තියන්න ඕනේ කියන එක හිතලා තමයි ගන්න ඕනේ. So logically argue, if we are to completely destroy a truck, think of which point on the truck that we should shot or we should target. Basically target කරන්න ඕනේ point එක මොකක්ද කියලා හිතන්න. What? No. Oh, velocities no? Hurry, directions දෙකට apply කරනවා. Directions දෙකට apply කරනවා. Then you will get two equations. I 1 and 2 එකේ තියෙනවා. එතකොට හරි. The driver's head better. Okay, it's I make it. Gilla ne man දැක්කේ නැහැ. Let's start. And it's not a sniper shot, it's a bomb. Right. Part A. A balloon is moving vertically upwards with a uniform velocity of 15 ms minus 1. A stone is freely released from the balloon at a height of 200 meters from ground, above ground. Right. But we know, since the balloon is moving, even though the stone is freely released from the balloon is moving, no? Then that stone immediately acquires the velocity, direction and magnitude of the velocity of that parent body, because balloon becomes a parent body in that scenario. And whatever the stone that is thrown out is the sister body, that is the detached sub-object. So it takes the direction and velocity of the parent body. So first thing is, now if I sketch the given scenario at the point where 200 meters from ground, here 200 meters from ground, this is freely released, but initial velocity the stone takes is 15 ms minus 1 because of the parent body. Parent body is moving, right? At the same instant, right? So let's say this is t equals 0, t equals 0. At the same instant means this should be t equals 0 again. Another stone on the ground is thrown vertically upwards with 15. Is thrown vertically upwards with 15. Right. Now these two motions are going to be, since this has an upward velocity, right? It is going to go upwards, travel upwards until it reaches the maximum point, and then only it comes back. This is the motion. And this one is a vertical motion, so it will go up and reaching a maximum point, and it comes back. Right? These two are the two respective motions. Right? Otherwise, this won't come downwards from the very point that is released. It has an upward velocity, so it goes up until this velocity becomes 0, and then only it returns. Okay, one, as observed by a person on ground. As observed by a person on ground. So simply that is asked with respect to or relative to the person on ground. Right? Relative motion. Relative motion means that is how someone else observes this. Right? In all scenarios, I mean by default we consider with respect to Earth, since we are on Earth, right? And if we need the velocity or displacement, acceleration, anything with respect to someone else, right? That is his perspective. That is called the relative motion, right? His perspective, the way that particular person sees, right? Last paper එකත් එහෙම question එකක් තිබ්බනේ. Relative motion එකක් තිබ්බනේ. මම explain කරා මොකක් හරි. Right, listen. So it's like this. Now if you are moving inside the bus, say if you are a passenger in the bus, right? We are a passenger and driver is there in the bus, and when the bus travels also, driver is at the same point with respect to us. Driver venamai and driver is at the same point. Distance between driver and the passenger doesn't change over time, which means there's no relative motion between the passenger and the driver. But if someone looks at us by being on ground, they see, or that person sees, that we are moving inside the bus. So we are not at rest with respect to ground, but we are at rest with respect to bus. Bus එක ඇතුලේ අපි දුවදු ඉන්නේ නැහැ, we are seated. So we are at rest with respect to the bus. Right? So if someone inside the bus sees us, so what they see is we are at rest. අපි දැන් බස් එකේ යනවා හම්බ වෙනවා කවුරු හරි. ඒතර කියන්නේ නැහැ බස් එක ඇතුලේ අපි 40ට 50ට යනවා කියලා. එහෙම වෙන්නේ නැහැ. බස් එක ඇතුලේ අපි හිටගෙන හරි ඉඳගෙන හරි නැවතිලා ඉන්නේ. We are at the rest. We are at rest inside the bus. Right? So බස් එකේ ඉන්නේ rest එකේ. But with respect to ground, bus is moving. ඒක තමයි මේ scenario එක. Now this is with respect to a person on ground. Right? On ground no. Then someone here as seen by this one. This person's world basically. This person's world. Right? So he will definitely see this upward 15. Right? Because he sees the balloon is moving upwards. මෙයාට balloon එක move වෙනවා පේනවා. So he sees this. Then for the first stone, I will refer this as the first stone, this as the second stone. For first stone, that is 15 ms minus 1 upwards, vertically upwards. 15 ms minus 1 vertically upwards. If someone sees this thing inside, I mean by being inside the balloon, what is the velocity? With respect to a person in the balloon, velocity of first stone with respect to a person in the balloon. 0. Not same, 0. Because balloon is moving with 15. With respect to balloon, this is also moving upwards with 15. No motion of these two, right? Then it is 0. Given sentence that is why it says it is freely released from the balloon. Balloon free. With respect to the balloon, it is 0. But with respect to ground, that is 50. Right? Yeah, 0. It's correct. මම කලින් කියපු scenario එකමයි. අපි බස් එකක ඉන්නවා නම් දැන් බැලුම් එකක් imagine කරගන්න අමාරු වෙනවා. If you are inside the bus, right? බස් එකේ say we are traveling, I'm going on a bus with a friend. දර අපි මෙහෙම ඉන්නවා and the friend is seated next to you. Right? There's no motion between two of you, no? Both of you are at rest on the seat. Then there's no relative motion between you two. With respect to the bus, with respect to your friend, you are at rest. But if someone sees from the outside on ground, then that particular person sees that we are moving with the bus. Right? That is a relative motion. Different objects, different bodies has different perspectives. That phenomenon is the relative motion. Right? What is the initial velocity of the second stone? Second stone is anyway that is on the ground, no? Then same. 15 ms minus 1 upwards. Part 2. What is the time taken by the first stone to reach ground? By the first stone to reach ground. Right. Then from starting point to end point, I'm going to use s equals ud plus half ad squared downwards. S equals ud plus half ad squared downwards. Downward displacement from here to here is 200. Right? Positive. And initial velocity is 15, but that is upwards. My considered direction is downwards. Then it should be minus 15. Minus 15t. Right? We are using the equation downwards. Gravitational acceleration is also downwards. So that is plus. Then half g t squared. Right? Simplify this. 200 equals minus 15t. This is plus 5t squared. Divisible by 5. 5 times 3 and 40. Then 40 equals minus 3t plus t squared. Right? So the respective quadratic equation is 0 equals t squared minus 3t minus 40. Factorize this. Find roots. Right? T and t minus 40 and minus 3, minus 8 plus 5. Minus 8 plus 5. Right? This answer is going to be negative, contradictory. Then T should be 8 seconds. No need to mention anything. If you put the sign of contradictory like this, that is enough. That is contradictory. So first answer for the second one, 8 seconds. For the second one, 8 seconds. 3. What is the time taken by second stone to reach ground? So we can apply the same equation. For second stone, I'll be using the same equation upwards. S equals ut plus half AD squared upwards. Right. S from starting point to end point, starting at ground and ending the motion at down, which means no vertical displacement. Right? No vertical displacement, 0. No vertical displacement, 0. Initial velocity 15, then 15t plus half. We are using the equation upwards now. G is downwards, so that is minus g minus 10 t squared. This gives minus 5. Take it to the other side. 5t squared equals 15t. 1t to t cancels. Simplify. T equals 3 seconds. T equals 3 seconds. 4. What is the time difference between the times obtained in 2 and 3? Time difference delta t is 8 minus 3, 5 seconds. Right? Time difference is 5 seconds. Clear, right? Any questions? Right. If no questions, we can move on to part B. Try part B again. 2 parts. Right. Again, I'll give you like 10 minutes. Part B. Question 1, part B. Right? Question 1, part B. If you have already finished part B, you can move on to the next 39. And ask if any questions from the discussed parts. Change in the second question. Second one, part B. Question 2, part B should be corrected as 2 identical balls. Two identical balls. What's the velocity of the truck you got? You? Oh, velocity of truck. Rear edge of the truck is at horizontal distance 125 meters from the vertical line through the point of release. From the vertical line to the point of release. From the vertical line. Point of release medana. Vertical line through the point of release is this. 125 meters. Again, horizontally 125 කියන එක තමයි. හරි? Point of release එක through යන vertical line එක කියන්නේ මේක. ඒකෙන් 125. truck එක මේ rear edge එක තියෙන්නේ මෙතන. Right? Correct? Right. Let's see. Right. Next. Part B. A 5-day aircraft is flying horizontally with a velocity of 72 ms minus 1 at a height of 128 meters above the ground to attack a set of identical trucks moving along a straight road with constant but different velocities. Right? Constant but different velocities. Constant velocities, but values are, magnitudes are different. The dimensions of each truck are 10 meters in length and 3 meters in height. At the instant, the bomb is released freely from the craft. Freely from the craft. Now, craft is being the parent body again. Then the bomb immediately acquires the direction and magnitude of the parent body. Then initial velocity of this bomb is 72 ms minus 1. And it is at 128 meters above the ground. 128 meters above the ground. Right? So to get an idea, try to draw a sketch. Then the idea of the question, idea and the understanding of the question is very much clear. That's the thing, right? In linear motion questions, that's a must-do thing. Then at the instant a bomb is released and the rear edge of the truck is at a horizontal distance of 125 meters from the vertical line through the point of release. Vertical line through point of release is this. Then from here, the truck is 125 meters away. Then from here to here, it should be 125 meters now. 125 meters. And these dimensions are given. Height of the truck is 3 meters. Length of the truck is 10 meters. Right? Part A. Find the velocity of the truck if it was completely destroyed. Right. Right. Now, you have to think of the point, the best point to attack to destroy it completely. Right. So let me give you a few points. Tell me what we are going to choose. Say this is point A. this is point B, this is point C, and this is D. This end is E. From ABCD, what's the best point to attack in the truck? Now think of the attacker's perspective. Now his target is to destroy this somehow, right? Around last paper question to clear the bus or something, right? Again, not to collide. Then meawa kelimma destroy kala දාන්න ඕන. Okay, what's the best point to attack on the truck? C. 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 Same. Online? What's the best point on the truck to attack? B. I will give you a hint. Hint is, now always when attacking something, right? A perspective again below, higher the vulnerability. What is vulnerability? Api attack karaddi, if that particular thing is in my vulnerable range, vulnerable in that range, in that risky range, right? Higher the range, higher the possibility of hitting, right? Okay, ships ala diyanawa, aircrafts ala diyanawa. If you are doing combined maths in relative velocity questions, that's there, right? Then always focus on being in the maximum vulnerable range, being within the maximum vulnerable range. The point is B, not C. Point is B. The thing is this. See, point is point B. If the target is taken to point B, see, if the target is taken to point B, if the target is taken to point B, from this point up to this point, throughout the length, this risk is involved. Because now when the bomb is reaching here also, truck is in the motion in this direction. So the method truck is not going to stop here once the bomb comes. Bomb it is in the motion. Right? Move in a gaman then bomb method move the Kohamat bomb make a hood right. Bomb is already on the hood. Then from here to here, that is vulnerable. In that range. Middle point but vulnerable range is only half. So therefore, in that attacking perspective, the best point to attack on this truck is point B. But it is correct. Point B. That is one decision you have to make. Right? It should be point B. This is the decision you have to make. Right. Now it's done. Find the velocity of the truck. Okay, since this is a relative motion, so let's consider velocity of the truck as V. Right. Since this is a relative motion, I'm going to apply relative velocities. Right? Last day question I'm going to apply relative velocities. Right? There are two basic ways. Relative velocity means with respect to someone else, with respect to means if that particular body is or the particular frame is at rest, how he sees, how that object is. Right? Now, I'm going to consider bomb relative to bomb. For bomb relative to truck. For bomb relative to truck, because if there are more than one moving objects, that is a relative motion. It is easier when you think of that relative motion, because in a relative motion always we are thinking as one is being at rest, as one is keeping at rest. Now if I need this relative motion with respect to truck, which means this is when the truck is at rest. When means if the truck is at rest, right? Then one method of applying relative velocity is now the truck is moving with velocity v. To make this take this to a stop, if a velocity of opposite velocity of v is given to the truck will be stopped, right? And as a standard, always we have to circle relative velocities. If you are marking relative velocities, there is a standard, right? Circle there is a standard. And if you are applying relative velocities, you have to apply the same relative velocity to each and every particle or the object on the same system. Then this is also v, right? So that is one way of applying. Then if this is at rest, if the bomb travels from here to here, it hits no. If this is at rest, then relative to truck. Truck is at rest now. Then apply S equals ut considering this motion. But for that, first of all, we need t. Let me find t first. S equals ut plus half at squared downwards. Now, vertical distance is from here to here only, that is 125 meters. Right? Then 125. Vertical initial velocity is 0 because initial velocity is horizontal. Perpendicular directions are neglected. 0 plus half. G is vertically downwards anyway. Right? Then plus 10 t squared. 125 equals 5 t squared. 5 and 125 cancels 25. T squared equals 25. T equals 5 seconds. Right? T equals 5 seconds. Now, mistakenly, if you put 128 or something, it won't get a perfect route. Right? 5 seconds. 5 seconds. Right. Now, if the time is known, you can apply this. Now, the time is known, apply this. Relative displacement. For bomb, for bomb. There's no relative motion here. With respect to Earth. Nothing is mentioned means this is with respect to Earth. This is relative to truck. Then all these terms should be applied respect to truck. So let me label bomb as B and the truck as T. Bomb as B and the truck as T. Then this is for bomb relative to truck now. Then displacement of bomb relative to truck, SBD. And U should be velocity of truck, initial velocity of, bomb with respect to truck into time. Time is independent. Time is not a relative quantity. Right? Now, this is the equation. No? Displacement of bomb with respect to truck. If the truck is at rest, displacement of the bomb should be from here to here. 125 plus this 135. Right? Then 135. Velocity of bomb with respect to truck. That is, take the resultant 72 minus V. 72 minus V into time 5 seconds. Simplify this. 135 equals, this cancels by 5. 135 over 5 equals 72 minus V. 135 can 27. 27. 27. Oh, 27. Then V equals 72 minus 27, 45. 45 ms minus 1. 45 ms minus 1. Listen, now if you didn't get what I did here in terms of relative velocities, another alternative method is, right, you can apply the principle of relative velocities, right, like this. So we know VAB is written as VAE plus VEB, no? Principle of relative velocities. Right? Apply it here. If you need velocity of bomb with respect to truck, this is given by velocity of bomb with respect to Earth plus velocity of Earth with respect to truck. Velocity of bomb with respect to Earth is 72 in this direction. Velocity of truck with respect to Earth is V. Then velocity of Earth with respect to truck is V to the opposite direction. Right? So we know we can write vector AB as minus vector BA. No? You can write vector AB as minus vector BA. Then this is 72 rightwards minus V rightwards. So this is 72 minus V rightwards. So this is what I wrote at once. Right? So if you are applying the principle of relative velocities, no need to mark circles. Two different methods. If you are using the principle of relative velocities, find it out and apply in the equation. But if you are considering relative velocities without applying the principle, you have to circle. Right? And another possible option is, still you can do the same question with respect to Earth, but In terms of the working, it will be lengthier. That's the thing. Otherwise, it is possible to do. It is something possible to do, but it will be a very lengthier working. Next, part B. Part B. After a few seconds, another bomb is released freely to target another truck moving with a uniform velocity of 45. What we have got is also 45. Right? What we have got is also 45, and the next truck is also moving with 45. At the instant the bomb is released, the rear edge of the truck is also at the same horizontal distance as in previous case. Right? Will this truck be destroyed or not? Give reasons for your answer. Definitely it is going to be destroyed. Same scenario, no? If there is at the same distance, definitely it is going to be destroyed. The calculated value is 45, so it will be destroyed. Right? Okay, then will the truck be destroyed? Then you have to say the truck will destroy. The truck will destroy. The truck will destroy. Or else just it will. ඊට පස්සේ explain කරන්නත් ඕනේ. Give reasons to your answer. Then write down. Write down. According to previous calculation. According to previous calculation. According to previous calculation. According to previous calculation. The truck is completely destroyed. The truck is completely destroyed. According to previous calculation, the truck is completely destroyed. When its velocity is 45 ms minus 1. When its velocity is 45 ms minus 1. When its velocity is 45 ms minus 1. Right? Okay. And one more thing additionally. Now assume in this part B, it was given as same conditions, and if the truck is moving with a uniform velocity 47, how to compare? How do you say whether it is going to destroy or not? Listen, if the same scenario is given as the truck is moving with a uniform velocity of 47, come again. Then in such a case also you should be able to check it out. How to check? How to check? 47 කියලා දෙනවා. Something different from this 45. 45 ආපු ගමන් it is for sure going to be destroyed, no? Nothing to think. මේක හදලා ඉවරයි. 47 කියලා දෙනවා. But if what happens, something additional, no? Listen. What happens if the truck is 47? If the truck is 47, destroyed or not? What's the logic? What's the logic? For anything that you say here in physics, there should be a justification, right? අනිවාර්යෙන් justification එකක් තියෙනවා. ඒක තමයි justification එක දැනගෙන ඉන්න ඕනේ. There's a justification. Justifications නැති නිකන් දේවල් නැහැ physics වල. There's a justification. How to check this? මේක check කරන්න පුළුවන්. හරියටම කියන්න පුළුවන් ඕන මොන point එකකද ට්‍රක් ඒව දින්නේ කියලා. You have to check it. මේ වැඩේම කරන්න පුළුවන්. Apply an equation and see. If this velocity is 47, now knowing the velocity, I'm going to check the relative displacement. එහෙම කරගත්තා නම් හරිනේ. මේ equation එකම apply කරනවා. Relative displacement of bomb with respect to is u b t t. This time is constant because either way, if it is hitting on the truck, it should fall only 125 meters, right? It is not going to hit on the truck. And time is constant. And I'm going to calculate SBD equals, for new case, it should be 72, 72 minus V, 72 minus 47. Like this. Into 5. check කරන්න නැතුව කියන්න බෑ. මෙතන වැලුව කීයද? 47 කියන්නේ 57 67 25. හරිනේ? 25 times 5 125 meters. Now what is happening? 125 meters කියලා කියන්නේ මෙයා මෙන්න මෙතෙන්ට තමයි එන්න හදන්නේ. Right? It is not going to destroy the rock. මෙයා එන්නේ මෙතෙන්ටනේ. ඕන්න මෙතන වදී. It is not going to completely destroy the rock. 125. එහෙම check කරන්න ඕනේ. ඉතින් මේක 48 කියලා දුන්නා නම් කොහොමද මේ ට්‍රක් එක පාස් කරලත් ඉවරයි. If it was given as 43 or something අනිත් පැත්තට check කරන්නත් පුළුවන්. හරි 43 නේද අපි නිකන් 44 වගේ ගමු. එතකොට නේ 44 වගේ දුන්නා නම් this is 72 minus 44 5. මෙතන කීයද? 28 නේ? හරි 28 into 5 කීයද? 140 නේ? මේ 28 හරිනේ 44 කියලා කියන්නේ 54 64 28 එහෙනම් මෙතනින් එන්නේ 140 නේ it is not going to hit the truck නේ truck එක 43 වලින් නම් එන්නේ 44 වලින් නම් එන්නේ අරග යනවා 140 the bomb is going to fall in front of the truck අන්න ඒ වගේ මේකෙන් decisions ගන්න පුළුවන් got it so that is what you should understand මේ දාලා බලන්න ඕනේ දැන් හිතලා කියන්න බෑ දැන් 47 දුන්නා ඊපස්සේ 47 7 එකක් තියෙන්නේ ඩිවයිඩ් වෙන්නෙත් නෑ නිකන් ඒ හින්දා එනවා එහෙම බෑ දාලා බලන්න වෙනවා නැත්නම් අපිට කිසිම ඩිසිෂන් එකක් කියන්න බෑ දැන් මේක 46 දැම්මොත් ඒ කියන්නේ වදිනවා 46 දැම්මොත් මෙතන 130 වගේ නෙන්නේ 130 එනවා කියන්නේ මෙයාගේ මිඩ් පොයින්ට් එකේ වදිනවා right අන්න එහෙම අපිට කියන්න පුළුවන් something additional so just know this is how you can argue this is how you should argue in that kind of a scenario is given right so let's move on question 2 9 8 ne right question 2 see එක different part එක ගන්න for question 2 for part A and B I will give you like 8 minutes question 2 A and B so if needed you can take down this right this is not task but this is something you should know and it is most probable highly probable to ask something like that if you got 45 45 ගත්තොත් මේ වගේ අපිට guess කරනවා කියන්නේ මෙහෙම calculation එකක් කරලා බලන්න පුළුවන් right for question 2 parts A and B 9 to give you 8 minutes right try linear momentum collisions linear momentum and collisions so part C it's light string part C yeah light string so if it is not given as a heavy string or a weighted string by default we consider light strings So if root answers are coming, right, roots in on it, I have to simplify the roots because this is an essay question. Then only option if there is a difficult root is logs, right? එහෙම root එකක් එනවා නම් logs වලටම යන්න වෙනවා. So what is a weighing balance? Weighing balance කියන්නේ it's a balance. Pan balances වගේ. So where you can stand up, right? අර තියෙන්නේ බර කියලා. Where you can stand up and the reading is shown in the balance. Weighing balances. Weighing balances කියන බර කිරණ තරාදි කියන්නේ. So with the pan, right? Small scale එකක් නම් you can get onto the pan, but in weighing balances we can get onto the pan and you can measure your own weight, own mass. For medical centers in medical centers, hospitals, right? You can get in and check the mass. Right, that's it. Right, first one, write the principle of conservation of linear momentum. Right, a theory part, right? Law of conservation of linear momentum. Law of conservation of linear momentum. What is law of conservation of linear momentum? Right, all keywords should be there. Right, this is what basically it should be. When there's no external unbalanced force acting on an object, when there's no external unbalanced force acting on an object, total linear momentum is conserved. When there's no external unbalanced force acting on an object, total linear momentum is conserved. When there's no external unbalanced force acting on an object, total linear momentum is conserved. Right, part B. Part B. Two balls A and B are initially at rest on a smooth horizontal table. Ball A starts moving with a uniform velocity of 30 towards B. Right. So before collision, ball A starts moving with 30 ms minus 1 towards B, which is at rest. Right. So this is what happens before collision. Before collision. and collides with it. After the collision, ball A moves at an angle of 30 to its initial direction. Right. So after the collision, ball A travels at an angle 30 to its initial direction, and B moves at an angle 45 to its initial direction of ball A, Right. So I'll consider this as X and Y. These two velocities, because we don't know the values of velocities. Right. The reason to mark X and Y with disinclination is it says from this direction, and so we know total initial linear momentum is only to the rightward direction. Then according to law of conservation of linear momentum, total final one should also be to the rightward direction, right? And these two can be rightwards. I mean, the resultant of these two is a rightward one. No? So that's why it cannot be something like here or something like that, right? direction total initial momentum is rightwards. Final rightwards. There's no vertical linear momentum initially. Then finally it should also be 0. Then these two should cancel each other as a momentum, right? We'll see. This is what happens after the collision. After, right? First one, apply the principle of conservation of linear momentum in the direction of initial motion of ball A. Right? Again, first one, along this direction, right? I told you these are identical. Then same mass, right? Then for the first one, mass into velocity m into 30 plus momentum is mv, right? Plus b is at rest, no momentum, 0. And here components are coming inclined directions. So this component is x sine 30 away from the angle x sine 30 towards the angle x cos 30 towards the angle. This is y cos 45, and away from the angle downwards this is y sine 45. These all components in blue. These all components, right? Then in this direction, about A, right, mass m into this particular component x cos 30 plus for B, mass is same, m, horizontal component y cos 45. Vertical components are neglected as it is perpendicular to direction of consideration, right? So first equation, 30 equals x cos 30 is root 3 over 2, no? Root 3 over 2, and y cos 45 is root 2. 1 over root 2, right? Then apply so this is enough. Even the first line is enough. Apply even the first line is also enough. Right? Part 2. Apply the principle of conservation of linear momentum in the direction perpendicular to the initial motion of A. Right? So I'll be using vertical upwards. For M, initial velocity was horizontal. There's no vertical velocity, 0. For B, it is anyway at rest, 0. And here, after the collision, for A, we have an upward component. Upward means positive components, x sine 30. Plus, for B, its velocity is downwards, that is opposite to my considered direction, that is minus y sine 45. Vector rules, right? Take this to the other side, then my sine 45 equals mx sine 30. M to M cancels. Y sine 45 is 1 or root 2, no? X sine 30 is half, right? Then these two are going to cancel. X equals 2y over root 2. 2 is root 2 times root 2. Then x equals root 2y. Right? Simplify karot cancel veno. If you simplify it, it cancels. Right? I will label this as 1 and this as 2. Right? And for the marking purpose, only the application is enough. Since we have a calculation followed by, I simplified it a little bit. Right? X equals root 2y. 3. Calculate the velocities of each ball after the collision. Right. Then we have two unknown variables with two equations. X is known from here. X equals root 2y. Plug it here and simplify. X equals root 2y. Yeah, it's correct, no? Right. Then from 1, you can solve this. 30 equals x is root 2y. Let's find y first. X equals root 2y into root 3 over 2. Right? Then root 2 to this cancels, root 2 plus y over root 2. Yeah, it simplifies. Then 30 equals y is common, y over root 2 is common. Then here root 3 plus 1 remains. Subject y equals 30 root 2 over, right? 30 root 2 over root 3 plus 1. This is the answer and it should be simplified. 30 root 2 over root 3 plus 1. Simplify. What is it? Check on. Root 2 is 1.414, right? Root 2 and root 3 are known values. $15.52. Online 58.252. 30 root 2 right? 30 root 2. 30 root 2 is 42.42. So the root 3 plus 1 is 2 point something. Then it cannot be a 50 thing. Or again, x I'm finding y. 2.73 to 15.52. 15.52. 15.52 ms minus 1. And we need x from here, x equals root 2y. X equals root 2y, y is, so if needed, you can plug this value, then root 2 cancels. Right? නැත්නම් මේක දාලා simplify කරන්න පුළුවන්. Right? Root 2 times root 2 is 2. Root 2 times root 2 is 2. 2 times 30 is 60. Then this is 60 over root 3 plus 1. $21.96. So I got these two check values. 21.96. Calculate the velocities, right? Right, start part C. 5 minutes. That's a small part. Part C, 5 minutes. Right, let's see. Right. Right. See, a string AB is fixed to a vertical stand. Right. Let me copy this down. (15 newtons), 12 newtons, theta, A, C, B. Right. A string AB, right, fixed to a vertical stand and passes over pulley as shown in the diagram. Weights 15 newtons and 12 newtons are suspended at point B and C respectively. At point B and C respectively, all right. B and C respectively, right. Calculate the tension of the segment AC, right. Now, even though this is a single string, now from here to here there is a single string, no, right? Usually tension of a same light string, right? Same light inextensible string is same, but when masses are suspended at a middle point, it changes, right? If a mass is suspended, it changes. So if needed, you can write an equilibrium equation for equilibrium and see, because now here from this t, horizontal component is going to be t cos theta, right? Then t cos theta equals t, which means they are different. So even though, keep this in mind, even though that's the same string, if masses are suspended at a middle point, right? If there is some kind of a distraction in the middle point, it changes. For the same string, without any distractions, if it was like this, it is same. If it was like this, something like this, throughout the string, tensions are same string. But here it is different. Then if a mass is suspended here, then it changes. Right? If the string is free at middle points, it will be same, right? Then let's say this is T1. This is the same segment, and it is same. And this is a different segment, say T2. This is the same segment again up to here to here to here. No obstacles, T2. Right? And I will take this as, consider this as T3. These are the tensions. Right. Now this is an equilibrium. Equilibrium means acceleration, resultant acceleration of the system is 0, right? If the resultant acceleration of the system is 0, which means in terms of forces acting along a particular direction should be equal to the forces acting along the opposite direction, right? So apply it wherever necessary. See, first I'm going to consider the vertical equilibrium of this, right? Then you can mention this. Considering vertical equilibrium of 15 newtons, then vertically upward forces equals vertical downward forces. Vertically upwards on 15, that is only T2. Vertically downwards on 15, that is 15. Which means T2 equals 15 newtons. Right? T2 is known now. Then from here, force frame of this mass is this one. Same thing. Considering vertical equilibrium of 12 newtons. Considering vertical equilibrium of 12 newtons. Considering vertical equilibrium of 12 newtons. Vertically upward forces equals vertically downwards. Vertically upwards, that is only T3. Downwards 12 newtons. So T3 is also known. Right. Now, this point is given as point C. Right. That point itself is also at an equilibrium. If there is none moving, that is at an equilibrium. Then consider the equilibriums of point C by considering equilibrium of point C, right? So first, I'm going to consider the vertical equilibrium. Vertically upward forces equals vertically downwards, vertically upwards. This is a component, inclined force action. Then away from the angle, there is T1 sine theta. Towards the angle, this is T1 cos theta, right? These all components in vectors upwards, T1 sine theta, T1 sine theta. Downwards is T3. These are the forces which belongs to C, right? T3, downwards in T3 with right, but T3 is known, 12. So here T1 sine theta equals 12, equation 1, right? T1 sine theta equals 12, equation 1. Then horizontal equilibrium, considering horizontal equilibrium, horizontally leftward forces equals horizontally rightward forces. Horizontally leftwards, we have T1 cos theta. T1 cos theta. Rightwards, only T2. T2 is known, 15, which means T1 cos theta equals 15. I will consider this as equation 2, right? Then tension and the angle, no, right? Both are there in these two answers, right? Easily, what you can do is if you divide these two, T1 cancels and tan theta comes, which means theta can be determined, right? Only theta divide these two, 1 over 2. 1 over 2. Left hand side is T1 sine theta over T1 cos theta equals 12 over 15. T1 to T1 cancels, sine over cos is tan. Then tan theta equals, this is 12 over 15 can 3 times 4 over 5. 4 over 5 ne? 4 over 5. Then theta equals tan inverse 4 over 5 can 40 over 5, 0.8. 0.8000. You have to check the anti-tan value of this tan inverse, anti-tan. Tan inverse බලන්න from natural tangents in the tan tables, right? Tans බලන්න ඕනේ. 4 5 නේද? හරිනේ. 3 times 4 3 times 4 හරිනේ. මේ කැල් එකේ ගහුවට එන value එක වෙනස් because you should get the value with degrees and minutes. කැල් එකේ minutes එන්නේ නැහැ. හරි? ඒ නිසා මේ ඔය value එක හරියටම ගන්න table එකක් බලන්න ඕනේ. 38 degrees 39 minutes. 38 degrees 39 minutes. 38 degrees 39 minutes. Have to check this from a log table. Log name, sorry, tangents table. Natural tangents. Natural tangents. Right? Then to find T1, there are two possible ways. Right? One is, we know sin squared theta plus cos squared theta equals 1, no? Right? මේ දෙක square කරලා add කරන්න පුළුවන්. You can square these two equations and add them together. Sin squared theta equals cos squared theta equals 1. That is 1. Or else, now theta is known. Since theta is known, which means sin theta is known. Sin theta කියන්නේ sin 38, 39. So you can check the value of sin 38, 39 from sin tables and plug and simplify. එහෙම කරන්නත් පුළුවන්. Right? Either way is fine. That is up to you. That is any preferred method to you. Both are possible. Let me do the rest of the simplification here. And I will go this way. 1 squared plus 2 squared. If you got two equations having sin and cos as variables, right? And if you need to remove theta from the variables, this is the only way possible to do it. Then first one, T1 squared sin squared theta. T1 squared sin squared theta. Plus from the second one, T1 squared cos squared theta. Right hand sides are 12 squared plus 15 squared. Right? Take T1 squared down. Then sin squared theta plus cos squared theta comes. 12 squared 144. 15 squared 225. Sin square theta plus cos square theta is 1. Right? Sin square theta plus cos square theta is 1. Then T1 squared equals, what's the value here? 369. Alright? Then T1 equals root 369. මෙන්න මේ root එක එතකොට ආයි 1 වෙනවා. 19.20. 21 කියලා තිබ්බත් කමක් නැහැ. Right? 19.21 newtons. 19.21 newtons. Right. Go to part D and write within 5 minutes. Part D, 5 minutes. 9:44.
Quick rundown why the tension changes on a fragment A to C. It took as different as well. I got the answer, but I didn't understand why it also. Yeah,
Simply, explanation is this. Simply, if these tensions were different, this joint is going to break. That's the thing. Sorry, if they were same, this joint is going to break. Equilibrium ලියලා බලන්න පුළුවන්. Now, if you think that it is going to be same, see what's happening. T cos theta equals T කියලා. T to T cancels. It says cos theta equals 1. Then theta equals 0. Cos inverse 1 කියන්නේ 0. Theta 0 කියන්නේ. What's the meaning? Tension එක same නම් මෙයා කියන්නේ then the string should be horizontal. එතකොට හරියනේ. එහෙම නැත්තම් මේක තියෙන්නේ නැහැ කියලා මේ කියන්නේ. That's the thing. Right? Angle එකක් එක්ක තියෙන්න බෑ නේ. කෙලින්ම මේකෙන් බලලා ගත්තේ. vertical එකෙන් ඕනම් බලන්නත් පුළුවන්. Is it clear now? Yes, okay. Now, in any case, if you assumed it as equal, you will get to stuck somewhere. You are getting a contradictory value, a contradiction. මොකක් contradiction එකක් ඇවිල්ලා තමයි ඔයාලට question එක කරගන්න බැරි වෙන්නේ. එහෙම contradiction එකක් ආවොත් if you got a contradiction, a contradictory answer, right? theta එක හොයද්දී theta ට එක්ක invalid value එකක්. Invalid values කියලා කියන්නේ cosine theta cos theta if you are getting something greater than 1. ඒ වගේ cases එන්න පුළුවන්. Contradictions. Right? ඒ වගේ mistake එකක් වුණොත්. Right, part D. A man of mass 70 kilograms stands on a weighing balance inside an elevator moving vertically upwards. Right? Okay, let's assume this as the elevator. Right? So weighing balance is this. Let's say this is the weighing balance and this person stands on the balance. Right? Weighing balances කියන එක දන්නවනේ නේද? දන්නවනේ? When it comes to weighing balances, it starts from the small scale to large scale වෙනකම්ම තියෙනවා. හැම එකම weighing balances තමයි. දැන් man කෙනෙක් නේ ඒතකොට මුට ඉන්න පුළුවන් weighing balance එකක්. ඒ කියන්නේ ඔය තියෙන්නේ නිකන් clinic වල තියෙනවා, hospitals වල, medical centers. ඒවා තියෙන පොඩි balance එකක්. Can be digital low, analog go, whatever it is. Weighing balance අර දැන් ඔයාලට බර කිරන්න කිව්වොත් අපි කරන්නේ මොකද්ද? Spring balance එකකින් කිරන්න බෑනේ. අර එල්ල. ඒතකොට ඉතින් අර fan balance එක ගන්න ගන්නේ. Fan balance එකට කියලා නගිනවනේ නැග්ගට පස්සේ. අර ඒකේ reading එකක් කියන්නේ that's a weighing balance. හරි? දැන් ඔකේ පොඩි පොඩි levels වල ඒවා තියෙනවා. අර kitchen එකේ එහෙම තියෙනවා නම් cake හදන්න හරි මොනවා හරි හදන්න අර චූටි ඒවා තියෙනවා. ඒ ඔක්කොම fan balances තමයි. Only the size and the maximum reading is different. ඊට පස්සේ ඔය මේ මෙතන Rosal tile එකේ එහෙම තියෙනවා. එළිම truck එක තමයි measure කරන්නේ fan balance එකෙන්. කියන්නේ weighing balance එක. දැකලාද? එහෙම තියෙනවා. අර ඒක හදන්නේ මොකක් හරි මේ clay එකකින්නේ. tile කියන්නේ මේ ceramic කියන්නේ මොනවද කියන්නේ porcelain. porcelain කියන්නේ clay එකක්නේ. ඒතර මේ දැන් clay එක measure කරන්නේ empty truck එක තේරෙනවනේ. truck එක measure කරනවා load එකෙද්දි and subtract the empty truck. යද්දි ආයි truck එක measure කරනවා. ඔය දෙකේ subtraction එක තමයි load එක. අර එහෙම එකක්. එහෙම මේ balance එකක් මෙහි තියෙනවා. මේ තල්ගහවිල Rosal එකේ තියෙනවා. එළින්ම truck එක දාන්නේ මේකට. දාපු ගමන් ඒකට දැන් මිනිස්සෙක් නැග කියලා ඒක හෙල්ලෙන්නවත් නැහැ. ඒක tons වලින් යන එකක් ඒකේ තියෙන්නේ. හරි? kilos නෙමෙයි. tons scales වලින් යන්නේ. right. anyway, ඒවා තමයි weighing balances. A man 70 kilograms. Okay. Then his weight is 700 newtons. Weighing balance inside an elevator moving vertically upwards. The elevator starts from rest. Okay, starts from rest. With uniform starts from rest and accelerates uniformly for 3 seconds. Accelerates for 3 seconds. At an acceleration 4. Sorry, acceleration for 3 seconds. For 3 seconds. Finally, it comes to rest with uniform retardation. Retardation is a deceleration. The apparent weight of the man shown as 490 while the elevator is moving with a retardation. Right. Okay, first thing. Reading of a balance, reading of a pan balance. They are generally called pan balances. They are generally called pan balances. If we are keeping the weight on a pan, on a plate, that is called a pan balance. Right? So cake, if that is on the pan, that is a pan balance. Balances අපේ types තියෙන්නේ පොඩ්ඩයි. Pan balances, spring balances, then the traditional balance. අර market එකේ එහෙම තියෙන traditional balance. ඊට පස්සේ triple beam, 4 beam, right? ඒ ටික තමයි balances තියෙන්නේ. Right. And reading of a pan balance is equal to resultant reaction on the pan. Right? නැත්නම් perpendicular reaction on the pan. So reaction එක mark කරගන්න. ඒක තමයි මෙයාගේ reading එක. Because with respect to that reading, that pan compressed, right? With respect to that force on it, it compressed, right? Then by the pan, on the man, there will be a reaction, no? Say that is R, say that is R. Equal and opposite reaction of this will be on the pan. And මෙන්න මේ reaction එකට තමයි pan එක sensitive. Pan is sensitive for that reaction on the pan. And that same reaction is on the man because they follows Newton's third law. They are mutual and opposite forces. They follows Newton's third law, right? Reaction on man by pan and reaction on pan by man, right? Okay, so that's a force diagram. First one. Calculate the apparent weight of the man when the elevator is accelerating, right? Elevator is accelerating. So let's assume that respective reading as R1 when it accelerates, right? For man, this application is for man. Upwards, F equals ma. For man, upwards, F equals ma, right? Tell me about this force, this R. Is it belong to man or pan? Prime man or pan? Belongs to man or pan? Huh? Newton's laws. Newton's laws. Newton's laws. This belongs to man or pan? Man. No, man. Pan, man. This belongs to man. M. Right? This belongs to man. Right? 700 belongs to man. This R belongs to pan. Right? Then mandane man ne man ke force frame එක. This is the force frame of man. Right? So upwards we have R, let's say R1. Api R1 කියලා ගමු. R1 minus 700 equals 70. Acceleration is 4. Right? Simplify this. R1 equals 280 මෙතනින් එන්නේ 280 කියන්නේ 980. Apparent weight shown on the pan is on the balance is 980. Balance reading is equal to perpendicular reaction on pan. ඕක තමයි මෙතන logic එක. Right? The logic is that balance reading of a pan balance is equal to perpendicular reaction on pan, and balance reading of a spring balance is equal to tension of the hook of the spring balance. ඒවා තමයි ඉතින් අපි දැනගෙන ඉන්න ඕන. Second one. Find the displacement of the elevator during the period of acceleration. Displacement. Right. If you need to find displacement, okay, first tell me which type of a motion is this? What's the type of the motion? What is the type of the motion? Komattam motions දෙකයිනේ දන්නේ. And for the other best, rotational motion is just started motion එක. Linear. Then apply a linear motion equation. And about this reading, then may reading it, this is the reaction on us. And this is something you can feel if you are inside an elevator, right? Vigilant anona make feel ano. Nikane podi තේරලා නැද්ද? ගාන හදලා පෙන්නලා කියන්න. ඩවුට් එකක් දින සමහරට ඕක තේරෙන්නේ නැහැ. ඩවුන්වර්ඩ්ස් එද්දි එලිවේටර් එක පොඩි නිකන් අර ෆ්ලෝටින් එකක් වගේ එකක් එනවනේ. ඇයි ඒ රියැක්ෂන් එක අඩු වෙනවා. දැන් මේක එක ප්‍රූව් වෙනවා ඉස්සරහට. Reaction decreases when it comes downwards. Right? මේ downward එක කියන්නේ ඉතින් මේක න retardation තියෙන්නේ. Upward acceleration is equal to downward. Upward deceleration is equal to downward acceleration. No? Same thing. So downwards එද්දිත් acceleration එකෙන් මේ වෙන එකම තමයි වෙන්නේ යන්නේ. That is what we feel because naturally when we are standing on the surface we feel our natural reaction. No? The weight එකේ reaction එක අපිට තියෙනවා. So that is something we are sensitive. දැන් ඒක අඩු වෙනවා නම් ඒකට අපි sensitive. ඒක අපිට තේරෙනවා. That is noticeable. ඒතර ඒක එලිවේටර් එක අර මුලින්ම යනවා නම් වගේ හොඳටම තේරෙනවා. පස්සේ පුරුදු වුණාට පස්සේ ඒක ඇත්තට ගානක් නැහැ. අර මුලදීම පළවෙනි දවසේ වගේ කියොත් මේ හොඳටම තේරෙනවා. ඒ කියන්නේ දැන් අර මේ feeling එකට, ඒ කියන්නේ මේ feeling එක කියන්නේ මේ තියෙන reaction එකට වඩා වෙන එකක් අපිට ඒතර දැනෙලම නැහැ. අරක තේරෙද්දි ටක් ගාලා තේරෙනවා පොඩි නිකන් floating එකක් වගේ තේරෙනවා. ඒක තමයි මේ. right. මේකට දාන්න linear equation එක s equals ut plus half ad squared. Right? Time is known now. Then s equals s1 කියලා ගන්නකො. U is 0, it's given. Half acceleration is 4, t is 3 squared. 9, again 18. 18 meters. Part 3. Find the maximum velocity attained by the elevator. Right. Okay, this is what you should understand again now. So it says it accelerates uniformly for 3 seconds and then it decelerates. So then maximum velocity is at the end point of acceleration. Right? Maximum velocity should be at the end point of acceleration because just after that point it starts to decelerate. Right? Maximum velocity should be at the end point of acceleration. Again, after 3 seconds. After 3 seconds. If you need maximum velocity, apply P equals U plus AD upwards. Right? So the logic is maximum velocity is at end point of acceleration. Maximum velocity is at the end point of acceleration. Just before starting deceleration. Right? Vmax equals, then U is 0 plus acceleration was 4, time is 3. Vmax is 12 ms minus 1. 12 ms minus 1. 4. Find the value of retardation of the elevator. Right. Now, when moves with retardation, the reading is given, no? 490. Reading is given. So again, what we do is, for the person, for man, apply F equals ma upwards. Right? Then upwards we have R. That R is given in the retardation as 490. Reading reaction 490 minus 700 equals 70 into retardation. Let's consider the retardation as A. Right, simplify this. 490 minus 700 210 minus 210 equals 70A, simplifiable. So A equals minus 3 ms minus 2. Right, so let that minus sign come. Then we know that's a verification that it is a retardation. Right. So if you are finding, don't plug the minus sign. Right. So as a habit, don't plug signs for the determining quantity. Let it come. 5. Find the displacement of the elevator during the period of uniform retardation. Before that, now this is what I was going to explain. Now, when it is accelerating upwards, the reading is 980. Right? Compared to his natural reaction. Natural reaction is 700. No? If he is standing still on ground, by the flow, the same reaction will be exerted. If he is standing still on ground. So natural reaction is 700. So therefore, when we go upwards in an upward acceleration, if you go upwards with an acceleration, you feel a higher reaction. Right? Higher reaction. So higher reaction again. If you are vigilant and conscious enough, there no. මැරෙන්නේ නැහැ නේ. ඒතකොට ඉතින් අර ඇත්තට බය හිතෙන්නේ මොකුත් නැහැ නේද? බය හිතනවා නම් තේරෙනවා. මේ හොඳට හිතුවොත් මේ මෙහෙන් අපිට එන ප්‍රෙෂර් එක වැඩි. ඒ කියන්නේ මේ ෆුට් එකේ තියෙන ප්‍රෙෂර් එක වැඩි. මේ නැචරල් ඉන්නවට වඩා දැන් අපිට මෙහෙම ඉන්නකොට එහෙම ප්‍රෙෂර් එකක් නැහැ නේ. නැචරල් නෝ. ඊට වඩා පොඩි අර පුෂ් එකක් තියෙනවා. ඒක ෆීල් ගන්න පුළුවන්. And if you accelerate downwards or decelerate upwards, either way it's same. It's a lesser reaction. Lesser reaction. මෙන්න මේ වෙලාවට තමයි අර floating වගේ එකක් තේරෙන්න ගන්න. Because that pressure on the foot and the force exerts on the foot is less than our natural value. අන්න එතකොට අපිට බය හිතෙනවා. බය හිතනවා කියන්නේ acceleration එක ගොඩක් too high වුණොත් බය හිතෙනවා. හරි? දැන් passenger elevators එහෙම ලොකුවට එහෙම යන්න හදලා නැහැනේ. හිමින්න යන්නේ මොකක් හරි ඔය shopping mall එකක හරි කොහේ හරි දැනග ගියොත් කොහේ හරි I mean institute එකක හරි shopping mall එකක හරි if you are on a passenger elevator ඒකට ඉතින් මිනිස්සු මරන්න ඕක හදලා නැහැනේ. ඕක හිමින්තරේ යන තමයි හදලා තියෙන්නේ. but මේක හොඳට conscious නම් මේක තේරෙනවා. හරි? අර කාගෝ කියන්නේ මොනවද? freight වලට හදලා තියෙන elevators වගේ තියෙනවනම් ඒව නම් ටිකක් high speed යනවා. අන්න ඒ වගේ එකක් ඇතුළේ හිටියොත් එහම හොඳට තේරෙනවා. හරි? ඒ මොනවා හරි site එකක වගේ. construction sites වල තියෙන. දැන් දිනවද දන්නේ නැහැ. in construction sites දැන් මිනිස්සුන්ට අරන් යන්න බෑනේ උඩට යනකම් ගෙදර වැඩ කරද්දී වගේ බඩු ටික. ඒතොර elevator එකක් දානවනේ. ඒ මොනවා හරි ඒකට වෙන නමකුත් තියෙනවා elevators වලට. නම නම් මතක නැහැ මට දැන්. අන්න ඒ වගේ එකක ගියොත් ඒකෙත් operator කෙනෙක් එමින්නවනේ. ඒවා ටිකක් high speed යනවා. Right. Anyway, so when you are using an elevator next time, be conscious and try to feel this. මේක හොඳට තේරෙනවා. මෙයා slow down වෙද්දිත් මේක හොඳට තේරෙනවා. slow down වෙද්දි එතකොට accelerate වෙන part එක. කියන්නේ මෙන්න මෙහෙම phase එකක් තියෙනවා. ඔය phases ටික පුළුවන් නම් අර conscious හිටියොත් තේරෙනවා. elevator එකේ මෙහෙම එකක් තියෙනවා. say you are going from ground floor to 7th වගේ. නිකන් ටිකක් යන්න ඕනේ ඉතින්. දැන් G එකේ ඉඳන් first එකට ගියා කියලා ඉතින් ඔයගොල්ලෝ ලොකු වැඩක් නෑ හොඳේ. ඊට වඩා extra case එක යන්න. ඒකටත් හොඳයි. මේ මෙන්න මෙහෙම එකක් තියෙනවා. මෙයාගේ motion එක first part එක starting from 0 නේ accelerate වෙනවා. constant cruise එකක් තියෙනවා velocity එකක්. ඊට පස්සේ decelerate වෙනවා. මේ phases තුන හොඳට තේරෙනවා අපි conscious නම්. හරි මේ points එක තේරෙනවා. right එහෙම යන්නේ දැන් එකපාරට accelerate වෙලාම යන්නෙත් නෑ. මෙහෙම තමයි යන්නේ. හරි accelerate කරලා ඒක පොඩි velocity එකක් ගත්තාන් පස්සේ මේ වගේ flow එකකට යනවා නම් මේ ටික uniform. right okay. දැන් බලන්න ඉතින් අනිත් දවසේ. නැත්නම් ඉතින් balance එකක් අරන් යන්න. ගිහිල්ලා balance එක තියාගෙන වාඩි වෙන්න. එතකොට ඒත් බලන්න පුළුවන්. මේ අතර මේක තේරෙනවද? මේක තමයි ඒකේ තියෙන physics එක. මේ අර first time යන කට්ටිය සමහර කට්ටිය ඔය පොඩි අය එහෙම මම අහලත් තියෙනවා මේ අර පොඩි කට්ටිය සමහරලාට දැකලා නැද්ද එලිවේටර්ස් අතර බය වෙලා අඬනවා. ඒ කියන්නේ වෙන මොකකට හරි බය වෙලා අඬනවද කියලා මම දන්නේ නැහැ. මේ මුන් මේකට බය වෙලා අඬන උන් ඉන්නවා. ඒකට දුකෙන් අහන්න ඕනේ යන්නේ කියලා. වෙන නැත්තම් වෙන කේස් එකක්ද දන්නේ නැහැ. හැබැයි ඒක ඇත්තටම මේක මේ ඒ කියන්නේ ෆේමස් කතාවක් වගේ මේක දන්නවා. අම්මලා එහෙම දන්නවා පොඩි අය ඉන්නවා. මේ අර එහෙම එකක් තියෙනවා. මොකද පොඩි අයට ඒක හොඳට තේරෙනවා. ඒගොල්ලන්ට මේ අර දැන් කොහොම ගිහින්ම නැහැ නේ ෆස්ට් ටයිම් වගේ යනවා නම් ඒකට නිකන් හරි අන්කොන්ෂස්. ඒ අන්කම්ෆර්ටබල්. අන්න එහෙම වෙද්දි උන් අඬනවා. වෙන මොකුත් දන්නේ නැහැ නේ. එහෙම තියෙනවද? අපිටවත් ඒක තේරෙනවා. right. Find the displacement of the elevator during the period of uniform retardation. හරි. ඒක rest එකට යනවා කියලා කිව්වනේ. right. then time එක දන්නේ නැහැ. displacement එක නහන්නේ. upwards දාන්න පුළුවන්. v squared equals u squared plus 2s. This is the only equation we have without time in it. Right? V squared final velocity is 0. And u squared, now this is applied from this point to, from the starting point of retardation. Starting point of retardation is the final point of acceleration, no? From this point to last point. Then initial velocity becomes 12. 12 squared, make a deceleration plus 2 minus 3, deceleration minus 3, s. Take it to the other side. Then 6s equals 12 into 12. Right? Make then 144 කියලා simplify කරන්න එපා. හොඳ 6 cancel වෙනවා. Keep it and let it simplify like this. Right? So s equals 24 meters. 24 meters. Displacement during the retardation 24. Displacement with the retardation 24. Right. Any questions? Any questions? We have discussed 2 structural essays and 2 essays. And this was actually the part 2 of paper 2. And next week, you are going to get part 1 of paper 3. Right? It will be a MCQ again, consists of 25 MCQs. Right? Again, an MCQ consists of 25 MCQs. Any questions? No. All good? I don't know. What about you? All good? No, right. All right. So if no questions, we'll wind up. Next week, get ready to write the MCQ. Right? Consists of 25 questions. And as I told you, the reverse class starts this Saturday. Right? If anyone is there willing to join, maybe your friend can account a friend or something also. Right? You can get my flyer from the channel and share it. Right? If anyone needs. All right then. Okay. Right. Then if no any questions, we'll wind up, right? Go safe and stay safe and work hard. Now, this is a new year is started. So you have started the new year with new hopes and new blessings, maybe new hopes, new targets, new goals. Then you should also be new, right? And the way you worked before should be updated now to the new version. Last day to a new version in the new year. You got 19 not weeks, months ahead of the exam from this month for 27 August, 19 months. So spend that time effectively. That's the thing, right? For 26-1, they have 30 weeks now from this week onwards, 30 weeks, right? Weeks you got 19 months, right? So use it effectively. That's the thing, right? So always, that is how you manage, that is how you work, because each and every one of you got the same timeline and every one of you have 24 hours, right? That is how you manage. ඒක ඇතුළේ තමයි මේ ගේම් එක තියෙන්නේ. මැනේජ් කරන විදිය. ඒතොර 24 hours වලින් පැය 12ක් නිදා ගන්නවා නම් it's up to you. ඒ කියන්නේ එහෙම ඉන්නවනේ. ඊට පස්සේ එතනින් 10 hours වැඩ කරනවා නම් it's also up to you. So whatever you do will come in return. එහෙම නෙවෙන්නේ කොහොමත් ඒක රිසල්ට් වල විතරක් නෙමෙයිනේ. right? මොනවා කරත් ඉතින් කරන එකනේ අර අනිත් පැත්තට රිටර්න් එකට එන්නේ. ඔය කියන්නේ if you do good, the return will also be good. එහෙමනේ. ඕකම තමයි ඉතින් රිසල්ට් වලට. It is always corresponding to the effort you put, right? That's the thing. All right, then we'll wind up 10:10. Right, we'll wind up. Go safe and stay safe. See you in the next class. Good night and goodbye.